I'm going to demonstrate the subtractive color theory, which helps explain how full color printing takes place. It's based on the premise that white light includes all color in the visible spectrum. So when you look at a white piece of paper on which printing is going to take place, what you're really seeing, for the most part, are equal amounts of red, green, and blue light. When combined, shows the color white. Let me demonstrate. I have a color wheel in front of me, and with it I'm going to try to simulate neutral white. I'm going to turn this wheel on, I'm going to spin it, and I'm going to turn a white light on. And when this comes up to speed, I'm going to turn it around, and you're going to see what appears to be neutral white. So let's try it now. Now as you look at that, you see something that simulates neutral white, the same color that we might use when we print on paper using the four-color printing process. Now I'm going to turn the motor off. And what you saw as neutral white was really a combination of red, green, and blue light reflecting back to your eye. So how do we do full color printing based on this principle? What we do is we have to filter out each of these colors to create what we call the primary printing colors of yellow, magenta, and cyan. Let me demonstrate. I'm going to put a mask on this wheel, a black mask, and I'm going to cover up the blue segment of the wheel. I'm going to lock it into place, and then I'm going to spin the wheel, and what I'm going to be doing is mixing equal amounts of red and green. You might ask, what will I see when I mix red and green? Notice as the wheel comes up to color, up to speed, you see the color yellow. Yellow is the first primary printing color. When yellow ink, or any process ink as we call it, is used in full color printing, these inks are so thin, they're transparent, and they act as filters that absorb and reflect various amounts of the red, green, and blue light already built into the white paper. So when we take a yellow ink film that's so thin that it's transparent and acts as a filter on the white paper, what it does, it absorbs all blue light that's reflecting back to your eye and reflects equal amounts of red and green light. Now let's go to the second primary printing color, which is called magenta. I'm going to cover the green segment of the wheel, and I'm going to mix red and blue. Notice as the wheel comes up to speed, what you begin to see is a color known as magenta. The color that you're seeing, it's not called red, it's not called purple, it's not called pink, it's not called maroon. The name of the color is magenta. Magenta is the second primary printing color. So when we take a magenta ink film that's so thin that it's transparent and acts as a filter on the white paper, what it does is it absorbs all green in the spectrum and reflects equal amounts of red and blue light. Now let's go to the third primary printing color, which we create by mixing blue and green. So I'm going to cover up the red sector of the spinning wheel, and I'm going to mix blue and green light. And as the wheel comes up to speed, what you begin to see is a color known as cyan. The color that you're looking at, it's not called blue, it's not called turquoise, it's not called aqua, it's called cyan. Cyan is the third primary printing color. So like the other colors, when I take a cyan ink filter that's so thin that it's transparent and acts as a filter on the white paper, what it's doing is it's absorbing all red light in the spectrum and reflecting equal amounts of blue and green light. So now you've seen 6 colors. Red, green, and blue, which are secondary printing colors, and yellow, magenta, and cyan, which are the primary printing colors. We add black to that to enhance detail and contrast, and we have our 4-color process, which employs yellow, magenta, cyan, and black ink. Thank you.